Good afternoon, ladies and gentlemen. I had a motor go bad on my air conditioning condenser, the fan specifically. Um, the motor itself still turns, but I went outside early this morning to hear the most god awful sound, and the actual compressor itself was really hot, and the fan was just barely moving. So highly suspect that the windings inside of here have gone bad. One indication to me was a little bit of rust. I guess has accumulated on the outside of this thing, which kind of suggests to me that maybe some of the insulation has broken down on the inside of here, and we got some bad juju going on. Um, just as a point here, the air conditioning unit uses a dual capacitor on here, one fan, one hermetic. The hermetic goes to the compressor. The fan obviously goes to the fan, and then the C is for the incoming power that charges that up. Uh, Long and the short of it, I hooked this motor up to a separate capacitor just to make sure that that capacitor was still functioning. Indeed, it does, but this motor does not. I can get a few rotations out of it, and it starts to heat up real bad, and there's a pole failure inside of here, and we have to replace it. This is not a big deal. For the uninitiated, this is a 48 frame motor, uh, made to NEMA standards, so don't get too hung up on the manufacturer's name. But what you are worried about is the shaft diameter, voltage, service factor is something to consider. The RPMs are pretty important too. Generally speaking, the more RPMs that you're turning, the more juice you're going to use. So a lot of these fans have modified RPM ranges. This particular one is 850. Um, I wouldn't get too hung up on that as long as you are uh, below 1100 RPMs or somewhere thereabouts. I think you'd be okay to duplicate this, but if you can get the same RPMs, at least the voltage will stay constant to what it had before. Um, if you do change a motor, sometimes the capacitor value does change, so you got to be ready for that. So it's not like you can just pop the motor in and hope that the capacitor works for it. They got to be kind of closely matched. Within a microfarad is not too bad or two, but you start getting into the tens or 20s of microfarad differences, it could very well affect the performance. This particular one being 5 microfarads, that is the running winding in this thing. It is not a tremendous amount, so but the newer ones are either more or less efficient depending on which way you go. This is only a quarter horsepower, so we aren't talking about large capacitance values for this motor in the first place. Conversely, the condenser would be the one that is drawing most of the capacitance from the capacitor here, and that is 40 UF, and that's at 240 volts. We got here 242 volts as average. And anyways, this is not the problem because the condenser does run still, even though it probably shouldn't. This does not turn. I'm not going to hook it back up to electricity again just because it was pretty faulty. But this motor has 3 leads that come out of it. You have a brown lead, a red lead, and a black lead. The red lead indicates this is your starting leg. You want your capacitor to go on one side of the starting leg. You would want incoming power to be hooked to this one on your fan side of it. Or excuse me, it'd be on the C side of it. And then the fan. And then as that was hooked up, this would run, but just it didn't want to. Anyways, the saga will have a video number 2, because this is just the first day I got this thing out of here, and tomorrow I'll take delivery on the new motor. Well, good afternoon, ladies and gentlemen. We have the replacement motor here for the 1/4 horsepower A.O. Smith that took a nosedive on me. This one is a 850 RPM motor, 1/4 horsepower, 1.3 full locked rotor amps. This one, energy saver, conservationist, 1/4 horsepower, 1.9 amps. Only real difference is this one is 1,075 RPMs. This one's 850. This one will turn a little bit faster, but I don't know about the energy saving part. For a 1/4 horsepower, there it's pulling quite a few amps, but I really don't have a choice right now, so here we go. The motor was inexpensive itself, so I guess I can't cry too much about that, but the efficiency isn't really all that good, only 63% I think. But to have air conditioning or not to have air conditioning, that is the question. Well, question's going to be answered, but yes, we're going to go ahead and put this in. It wires up a little bit different as far as the wire colors and all that good stuff, so I'm going to work all that out. Apparently this motor is bidirectional, and we will need it in the CCWLE, or excuse me, the CWLE, not CCW, CWLE. So that's clockwise on the lead end. And luckily enough, this one comes from the factory pre-wired that way. To swap this one, it's got a really neat connector. You just turn 180 degrees and put it back together, and there you go. But anyways, we will go ahead and install this in the air conditioner unit, and I'll go ahead and use the stock plug-in just because it's very convenient, but I'll have to solder all these leads onto those leads and make that happen. I'll do all that off camera, and we'll pick it up back at the air conditioning unit outside. Stand by. Well, ladies and gentlemen, as you can see, the fan replacement went well. It's a little bit faster than the OEM fan, but all said and done, we'll take it.